In this video, we're going to look at coordinate geometry. In particular, we're going to look at straight lines. So for M3, we will be going through and we'll be looking at the general equation of a straight line. We'll be looking at the gradient of a straight line, midpoint of a straight line, and the length of a straight line, and also a little bit about parallel lines. Okay, first of all, the general equation of a straight line. General equation of a straight line is y equals mx plus c, where m is the gradient and c is the intercept. So the gradient is basically the slope of a line. So a positive gradient slopes upwards as you move from left to right, a negative gradient slopes downwards as you move from left to right, and c is a y-intercept. So c is where your line, your diagonal line, cuts the y-axis. So the steeper, the higher the value of the gradient, the steeper that it is. So if you've got more than one, is considered to be steep. Equal to 1, it is sort of going at 45 degrees, and less than 1, it is quite shallow. Okay, next thing we've got here is vertical lines. Vertical lines are in the form x equals a. So for example, like x equals 6 would be a vertical line going through 6 on your x-axis. Horizontal lines are in the form y equals b, again where it's a vertical line horizontal line going through b on the horizontal axis. This first example says, identify the gradient and intercept of the following, and where appropriate, and sketch the graph. Okay, so first thing you want to do is remember y equals mx plus c is your general equation of your line. So in this one, you can see your m is just the coefficient of the x, so that's the number in front of the x once it's in that form. So m is equal to -3 and your c is equal to 5. So if you just do a sketch, so that's all you need to do for your x-axis and y-axis, and it has a positive y-intercept and it has a negative gradient, so it is that sort of form. And then just label your line whatever way they give it in the question is sort of good practice to do. The next one, first of all, you've got to rearrange to get it into y equals mx plus c form. So I'm going to do that by dividing across by the 4. So the coefficient of the x at the minute is 1. 1 divided by 4 would just be a quarter, so it's quarter x. And -2 divided by 4 would be -2 over 4, which is -1/2. So your m is equal to 1/4, so positive gradient this time. And your c is equal to -1/2. So again, when you draw your axes, mark on where your origin is and mark on your intercept first. It was -1/2. So there's -1/2, and it has a positive gradient, quite a shallow one, but there we are. And label your graph as it was given in the question. So in the question it was given as 4y equals x minus 2. Your next example is a y is equal to 8, and if we look up here, we can see y equals b is a horizontal line where b is a point where the line crosses the y-axis. So y equals 8. We just zoom in on this one a wee bit. There's your y-axis, there's your x-axis, mark on your 8, and there we have our line y is equal to 8. And that's it done. So there we have 3 examples. One straightforward one where you've got y equals mx plus c form. Another one we had to rearrange to get into y equals mx plus c form, and then just a nice easy horizontal line. Okay, next of all we have got midpoint and length of a line. We have 2 equations. So for 2 coordinates where you've got first coordinate is x1, y1, and the second coordinate is x2, y2. We can calculate the length of the line between them, and also midpoint, and by these formulas. So the length formula is, and I'm going to give you another way of saying this one, length could be equal to, and how I really remember it is x difference squared plus the y difference squared, and it is a square root of all that. But the other way, the more algebraic way I suppose, is what I've highlighted, square root of brackets x2 minus x1 squared plus brackets y2 minus y1 squared, and that comes from Pythagoras' theorem. So I'll just show you where that comes from. So if you imagine you've got a point here and a point here, and you want to find the length between them, you can create a wee right angle triangle, and this is your y difference, and this is your x difference. So remember what Pythagoras' theorem says. It says the square on the hypotenuse is equal to the sum of the squares on the other two sides. So this length here, L squared is going to be equal to your x difference squared plus your y difference squared. So then if we bring that square across, it becomes a square root. So L then is equal to the square root of your x difference squared plus your y difference squared. So we're going to look at these two examples here. Just get rid of all of that mess. So we have got, find the length first of all of these 2 points, and then we'll go back and look at the midpoint formula. So the length between 2, 7 and 5, 3. So your length is equal to the x difference. So it's going to be 2 minus 5 squared plus, and then it's going to be the y difference, which is going to be 7 minus 3 squared, and the square root of all that. If you do that out, that's going to be the square root of 2 minus 5 is minus 3 squared, 7 minus 3 is 4 squared. When you do that, and just be careful to use the brackets on your calculator, if you're showing all your working out, that's going to be just minus 3 times minus 3 is going to be 9, and 4 times 4 is going to be 16, and that works out to be root of 25, which is 5, and we don't know what it's going to be, so we'll say 5 units. Okay, if we go back up here and look at our midpoint, the midpoint is the average coordinate. So you take your x1 value. So if we look back at our x1 values here, you've got x1, y1, that's one of your coordinates, and then x2, y2, and to get the midpoint, you add the two x values and divide by 2, and you add the two y values and divide by 2. So that's how we get our midpoint. So it's just the average of them. So it's like the mean of them, I suppose. If you have the mean of two numbers, you add the two numbers and divide by 2. So here for the midpoint is going to be equal to 2 plus 7, and then you're dividing by 2, and then 5 plus 3, and you're dividing by 2. 2 plus 7 is 9, and sorry, that should be 2 plus 7, that's wrong. Let's go back through that. Sorry, my x values are 2 and 5. My y values are 7 and 3. And 2 plus 5 is 7, and divide by 2. 7 plus 3 is 10, and divide by 2, which becomes 3.5 and 5 just. Okay, next bit is parallel lines, and parallel lines have the same gradient. Basically that is it. So if you imagine you've got a line here and another parallel line, they have the same gradient and they will never meet. They're always going to be the same distance apart. So a bit like train tracks, they're never going to meet. They're always going to be the same distance apart. They always have the same gradient. So here I've given you an awkward one here. It says write an equation of a line parallel to this thing. So first of all, I would rearrange to get it in the form y equals mx plus c. So it makes it easier to read off the gradient. So we've got 3y is equal to, just brought that positive 2x across, it becomes negative 2x and plus 17. Then y is equal to negative 2 over 3x plus then 17 over 3. There is no need to change this. We don't really need this bit. The bit that we're interested in is this part, which is the gradient. So this has gradient equal to minus 2/3, and if we're parallel, then our gradient will also be the same. So our gradient is also going to be minus 2/3. So the line I'm going to say, just say our line could be y is equal to minus 2/3 x, and I'm just going to say plus 1. But this number here that I've highlighted in blue, this could have been any number at all really, because there's an infinite amount of parallel lines that are lines which are parallel to our original line that they give us. So as long as it's got a gradient of minus 2/3, we're good. Okay, the last thing we're going to look at is finding the equation of the line. So let's go back to basics here. The most basic thing we have is our equation of the line is y equals mx plus c. So to find the equation of a line, you've got to find your gradient first, and then we can substitute in a point hopefully and find the c as well, and then you'll have your general equation of your line. So let's have a look at our gradient formula. Again, if you've got the points x1, y1 and x2, y2, the gradient can be found using this formula. So m is equal to y2 minus y1 over x2 minus x1. And another way of saying it is the rise over the run. And I know an awful lot of people like this way of doing it. Let's just look at what is happening here. So if you imagine you've got 2 points, you can find the gradient of this line by creating a little right angle triangle. And it is this vertical change, the rise, over this horizontal change, which is the run. And this one would have a positive gradient. If I looked at a different one which had a negative gradient, this time the rise is going to be negative, so that's how it's going to get it, and the run is going to be positive, so that's how it's going to get a negative gradient, because the rise will actually be a negative number. So a negative divided by a positive gives you a negative overall. So we're going to look at a couple of these. So we have to find the gradient first of all. So it said if you may have to find the gradient, you may not. So once a gradient is known, it can be substituted into y equals mx plus c, and one of the points can be used to find c. So in this example it says find the equation of your line. So if it doesn't give you your gradient, you've got to work that out. So for part A, let's read the question. It says find the equation of a line which has a gradient of 5 and an intercept of minus 7. So m is equal to 5, and it actually tells you in the question that your c is equal to minus 7. So you could directly write that in as 5x minus 7. But I know an awful lot of people don't like doing it that way. So I'm going to pretend that I haven't realized my c is equal to minus 7. But that's what that means, remember. If you go through the point 0 minus 7, that's on your y-axis. So minus 7 is on your y-axis. So that will be your intercept. But a lot of people don't like that. So we're just going to go with putting your m into your equation, general equation, y equals mx plus c. And now we're going to just sub in 0 minus 7. So replace the x by 0 and replace the y by minus 7. So instead of y, you write minus 7. Instead of x, you write 0. Very common mistake for people to make here. People do 5 times 0 is 5, which is nonsense. Anything times 0 is just 0. So it's just minus 7 is equal to 0 plus c. So which means c then is equal to minus 7. And then you must remember to rewrite your equation then, putting in your constants you've just found. So m was 5 and c was minus 7, and that's you. Okay, part B. I think I'll just do part B up here so we can see the question. You want to find something with a gradient of 3. So m is equal to 3. So straight out off the bat then we know y is equal to 3x plus c. And we also know it goes through this point. So we'll just say sub in minus 3, 10. So that means 10 is equal to 3 times minus 3 plus c, which means 10 is equal to minus 9 plus c. Bring that minus 9 across, you'll have 10 plus 9 is equal to c, so 19 is equal to c. And again, rewrite your equation. Y is equal to 3x plus 19. Okay, part C is our only one of our examples where we actually have to work out the gradient. So first of all, it goes through the point 1, minus 3, and 5, 5. So your gradient m, you work it out using your formula, y difference over x difference, or rise over run, or whatever way you want to say it. So here I've just said y difference over x difference, and I'm going to say start with this y value. So if I start with that one, I'm going to have 5 minus 3 over, and then I'll start with this, I will start with this x value. So notice I've started with the same. I started with the same coordinate both times, and that's important that you do that. So it's going to be 5 minus 1. So that tidy up that top line. 5 minus 3 is the same as 5 plus 3, and then 5 minus 1 is just 4, and then that becomes 8 over 4, which becomes 2. And then all we do is sub in one of those points. So you could sub in either one of those points. I'm going to sub in the one with the two positive numbers. It might be a wee bit easier to use. So sub in 5, 5, which means 5 is equal to, sorry, up here I should have said y is equal to 2x plus c. So then that becomes, sub in your 5, 5 into y equals 2x plus c. It's going to be 2 times 5 plus c. So 5 is equal to 10 plus c, which means 5 minus 10 is equal to c, or minus 5 is equal to c. So your answer is y is equal to 2x minus 5. Okay, and we could just check that by putting in this point just to see when y is equal to minus 3, 2 times 1 is 2, and minus 5 would give you minus 3. So this point I've now highlighted in yellow will work for us. Okay, for part D here, we've defined the equation of a line which is parallel to y is equal to minus 5x minus 11. So that means the gradient of this line is equal to minus 5, which means our gradient, if we're parallel to, our gradient is also equal to minus 5. So what we know, our line is minus 5x plus c. And then we'll sub in this point. We'll sub in to 15, which gives you 15, my y value, is equal to minus 5 times 2 plus c. And we'll just continue that over here. That means 15 is equal to minus 10 plus c, which means 15 plus 10 is equal to c, which means 25 is equal to c. So your c is equal to 25. And your last line, y is equal to, and that's going to be minus 5x plus 25. So that is it. We have covered our general equation of a straight line. We've covered sketching graphs. We have covered gradient, midpoint, length, and also finding the general equation of a line.